Hello guys, in the previous video we managed to get the Advent of Code Day 4 part 2 done, and we started to work on the Day 5 part 1, but we didn't manage to get that room. So I was thinking that let's try to continue solving it and see can we manage to finally get it done. But yeah, without further ado, let's jump to back to the code and connect the runtime. Only change that I did between the last and this video was that I created a new notebook just with this day 5 contents, since the previous notebook started to feel very sluggish. But yeah, let's start. So previously we got the answer of 4922. Now since this was a bit unknown, or we didn't have any clues, or I didn't have any clues how to get this, or what could be the reason. So I was thinking that instead of using the actual input, we could for now just create new inputs and rules and then the reports just with the example data that we have here. So what we could do is that we get these, and these are the rules, and let's paste them, and then we can already do the splitting. Now we should have the rules there, and then we could use these reports. Yes, and do the same splitting here as well. And then if we run this, we should have the rules and reports available. Or was it updates? The variable that I used for these updates. Okay. Then let's change it to updates. And we can double check that indeed we have 6 updates and 21 rules. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 8, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So everything looks as it should. Now if we run these, we can get the value of 3 and then 137. So if we check the example, okay, so we have so number is correct, but the amount of mid-page numbers is correct, but then the numbers itself are not. Let's see what we have there. So we have, okay, interesting. So this okay, so the issue is this, because now it's 61, 52, 53, and then 13, even though it should be 29. Okay, so let's see if we print the update that was applicable. So we can see that they match, so they are exactly the same. But why this 13 is then the one that, so what we are getting here, maybe we could print this one and then position. So let's print the position or index basically. Index and mid number. So if you want to get the index, then we will just do this. Yes. And now we can run this. We want to remove that one since it isn't anymore applicable, and then remove that one. Yeah, that one actually, yes. Why it says every time the mid number index is 2? Now I'm wondering, is the rounding working correct? So if you have, so basic length is 5, and then if we split it, or divide with 2 and then round it up, it will be 2. Okay. Then if it is 3 and then we divide it by 2, it is 2. What if it's 10? It's 5. There is some like, because if you think about it, this rounding behaves wrong now. So basically we want to actually cast it to be int. So then it's 2, as it should. But then if we divide by 3, then it's 1. Yes. So instead of rounding, let's use integer. Actually, this now explains a lot. Now we are getting the same result. So if we run now the full data set and take the prints out here, and run it now like this, 10,593. And can't recall what was our previous answer, since it's not showing it anymore here. But let's test this one. Too high. Oh, sorry. We need to run that as well, and then okay. So this was not run, so hence the code was using the old rules. Yes, so we managed to get it done. Nice. So now we can continue with the part 2. Let's clean this up before we do like this. And we can clean these up as well and remove this test bit that we did have there. And then we can just add A5 part 2 and the new code block. Okay. While the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. For the above example, here are the 3 incorrectly ordered updates and their correct orderings. After taking only the incorrectly ordered updates and ordering them correctly, their middle page numbers are these. Adding these together produces 123. Find the updates which are not in the correct order. What you get if you add up the middle page numbers? Okay. So maybe easiest thing to start with is just to get all updates that are first of all wrong. We can do, or we don't even need that one. Neither we can rename this to be incorrect updates. Yes, and then we look through the update. We can remove this one. And if it's inapplicable, then we will just add the update to the list, and then we should have some items in the list. 107, okay. So basically, now we have the updates. What we want to do for them is that we want to loop them through for update in incorrect updates this time. And first of all, we want to get all the applicable rules. And then what we basically need to do is to make sure that this position 1, position 2 are so that position 1 is before position 2. So if we go through the applicable rules and we get the position, so we already know that these are wrong, so we necessarily don't need to even get this position 1. So position 2 tells us that where the second number is, and basically what it tells us that it gives us also the index where we need to move this rule, the first value or first number in the rule, and it is just before this one. And then it should be already quite good. So how we can do that is that maybe we can actually do updated updates or fixed updates. It's better. I want to just split this into multiple steps. So basically, I think we need to actually make a copy of this array. So from copy import copy. I'm afraid that it will kind of, or not sure, maybe it's not necessary, but let's see. So we want to have a copy of the update. And after that, we want to get applicable rules and then loop them through. Here we know that, or actually we want to get the position of the one because we need to delete it and pop it back in. So basically we want to do update dot pop position 1, and then actually we could do it like this. So if we pop it out and then get the position 2, because now there is less items in the array, and then if we update dot insert, yes, insert, it wanted the index first. So if I want to actually test this out first. So if we have array of 1, 2, 3, 4, and then we insert something in the, we want to add something before 3. 3 is in the index 2. But so if we add 5 there, and then we just print the A, yes, it got pushed. So we want to exactly add the item before or in the position of the position 2. And now after every rule is went through, we can do fixed updates. There's or something for some reason. Append update, and then we could run this. Okay. If we just check how the fixed updates are looking, that's beautiful. Looks like it should. And what we want to do is basically now do this. So we have the exact same thing. Get the middle numbers. So basically for we can have the page number sum, and let's put it 0, and then for update in fixed updates, then we want to basically do this. Since we know that it should be applicable, we don't need to fix or check any more that how many or do the rules match or anything. Just loop these items through. Then if we run it, we get 6,328. It sounds quite much. But then if you think about that, we had only 107 of those. Yeah, it's kind of aligned. Previously we had 85. Result was 4,662, and now we have 107, and it kind of increased around the same factor as the item count. So let's check, was this correct? It is not. That's not the right answer. Your answer is too high. Okay. So let's maybe do double check then. So if we first, since we first got the incorrect updates, let's use the example data to confirm that are we talking in the same way? Yes. And then the second one was like this. And then the third one was like this. Incorrect updates. And then I think we need to get these rules. Or actually, let's do it a bit differently. So let's also double check that our incorrect updates code works. So if we just set updates and then let's split it up and then rules and then split this up as well. And then actually let's copy this. So if we run this, we can actually delete this one and then we run this. We should have 3. Okay, let's double check also that which ones they are. So in example, the problematics were 75, 97, 47, 61, 53, correct. Then we have this smaller one or shorter one, 61, 13, 29, correct. Then we have the last one, 97, 13, 75, 29, and 47. Okay, so we can confirm that this works. Then if we run this block, we should have fixed updates. Fixed updates. And we can see that they are indeed different. Okay. So we need to run them. We need to run those rules. Now I'm actually, yeah, true. So it might not be enough that we run this. Okay, what happens if we just run for I in range? Let's say 3. Does it change the results? At all? Now I'm wondering, yeah, this is interesting. So it is not just, it's not that simple. Okay, interesting. So rule inapplicable rules. Okay, actually, I know one thing that we need to, or we could do, is that we could check that is this rule that we are currently on, is it one that is already kind of correct, or if not, then so if this is like this, then we can just continue. Let's see, do we get any different results now? So if we run it now, we run it. Okay, we got kind of better looking results. What if we do it like this? Then can we just, let's actually add one additional block. Okay, so now it actually did make it. These are correct, yeah. So the problem is that, or was that, we needed to loop the rules through multiple times, and this gives 123, which it is. So again, so now we just need to first run the initial data set in the memory. And then run this block. Then we can get the incorrect updates. Let's check how many we have. 107. Still looks good. And actually we want to do it so that it's length of the applicable rules. There is a way to optimize it, but for this, I think should be quite good. Fixed updates, we have a list of them there. 5,900. Let's try that one. It's definitely lower than the one that we already had or previously had. And when we submit that one. Okay, nice. So we managed to get that working. That was day 5. I think it's good time to pause here so that the video won't get too long. Thank you for watching. If you enjoyed the content, drop a like and subscribe to the channel, and see you guys next time. See ya!